Autodesk PowerMill 2017 includes the turning functionality, allowing manufacturers to make better use of their 5-axis mill turn machine tools. PowerMill provides a number of standard features including turning specific block, new curve creation tools, separate view controls, as well as turning features, tools and toolpaths. We start by creating a cylindrical block using simple inner and outer diameters. Once done, we use a new curve creation tool to create a spun profile. To access this, simply create a new pattern and open the curve editor menu. The spun profile icon is available from the top toolbar. A preview plane helps identify which axes to use from the curve creation. PowerMill generates a profile that accurately represents the volume that would be formed if the part was rotated around the axes. To control the extents of machining, PowerMill includes a series of turning specific feature types. To create a turning feature, we must first define a single open curve that represents the area to be machined. In this case, individual profiles can be created by copying and trimming the spun profile generated previously. Curves have been defined to represent the outer profile and 2 separate grooves. PowerMill offers 4 new turning feature types, these being outer profile, grooves, faces and bores. To create features, we simply select the curve, open up the feature editor menu and click apply. The same process is done to define all turning features. For the face feature, we only need to define a position along the turning axes. This can be done by entering a specific value, or as in this case, using the grab handles to dynamically match other geometry on screen. In this example, we will drag the feature position to match the diameter of the block. With our features defined, we can consider the tooling. PowerMill provides 2 new types of turning tool, each suiting different machining applications. Creating a turning tool in PowerMill is very similar to defining a milling cutter. Choose either a profiling or turning tool, and then use the menu to enter the key dimensions and settings. Once the tool type is defined, we can choose from a number of standard tip types and modify the inscribed diameter or the tip radius to suit our needs. If your specific tip is not included in the standard list, PowerMill allows it to be defined using a sketched pattern. From here we can choose a suitable tool holder. PowerMill offers 2 types, rectangular or cylindrical. Alternatively, more complex tool holders can be imported as 3D CAD models. Once the tooling has been created, we can begin to define the turning toolpaths. PowerMill provides roughing and finishing toolpath strategies for facing, profiling, grooving and boring. These can all be found under the dedicated turning strategy dialog. To start off, we will rough the face of the block. We need to make sure we have the correct feature group selected. Next we choose which feature we would like to machine and activate the correct tool. At this point, we can define key parameters, such as thickness and depth of cut. Once all settings are complete, click apply, and we can see the turning toolpath appear on screen. Face finishing uses similar options as face roughing, with addition of parameters that defines the thickness let on by the previous roughing operation. This ensures PowerMill machines stock in a safe and controlled fashion. Next we will consider the turning of the outer profile. PowerMill provides a number of toolpath styles including turning, facing or back facing. The style of turning chosen depends on the orientation of the cutting tip we plan to use. Additional controls allow parts to be programmed to suit the specific needs of the programmer. One such control sees independent X and Z thicknesses settings. Undercuts are detected with additional controls given to decide how best to react. PowerMill can adjust the tool automatically, remove all of the undercut areas, or ignore the undercut entirely. We will continue by calculating a roughing toolpath. Here we can see the program includes a profile pass at the end. We finish the profile in a similar way to facing. As well as defining the previous thickness, we can control the number of cuts required. The override stock option in the limits page allows a curve to be selected to represent the stock being cut. we can finish the remainder of the outside profile with grooving toolpaths. We continue by selecting an appropriate tool and making sure the grooving feature is selected. As before, key cutting parameters are entered into the turning toolpath form. The style of turning can be set to width or depth first. We then enter appropriate thicknesses and values, as well as grooving specific parameters such as depth of cut. Plunge the center first and various pecking options. When all parameters are correct, the toolpath is calculated. Finishing the groove is a lot simpler, as the amount of material to remove is small. We only have to define the cut correction, side lift off distance and thickness. An additional option to force the cutting tool to dwell at the bottom of the groove ensures the swarf is detached from the tool before it withdraws away from the part. The addition of turning in PowerMill greatly enhances the capabilities of manufacturers to produce complex parts using 5-axis multifunctional mill turn machine tools.